Hi and welcome back to another LeetCode video. Today we're looking at LeetCode 3271, hash divided string. So this is a medium problem, and if you're new to my videos, I approach them in interview practice mode, which means I'm going to be very thorough in the way that I approach the problem. I will first, I basically simulate what I would do in an interview, right? So I'm using LeetCode to practice for interviews. That's what I'm doing, and I'm just recording it for you guys. So what I do is I read through the problem description first to understand the problem. I will ask about the constraints, and on LeetCode that means I'll look at the constraints. I will then look at some examples, maybe work through them to get a better understanding of what the problem is in case I don't know how to solve it, and or just to make sure that I understand it correctly. And then I will propose a solution with runtime and space complexity before I write a single line of code. And when I get buy-in from the interviewer to implement one or another version that I have proposed, then I would implement that. And before I'm done, I would step through the code with example cases with my mental debugger to make sure that I didn't miss any edge cases or don't have any syntax errors or other bugs, or then run the test cases. So exactly what you would do in a normal interview as well. Cool. Long story short, let's try to understand the problem. So, okay. So we are given a string s of length n and an integer k. So string s and an integer k, where n is a multiple of k. Integer where n is, okay. Your task is to hash the string s into a new string called result, which has the length of n divided by k. First, divide s into n divided by k substrings, each with a length of k. Then initialize the result as an empty string. For each substring in order from the beginning, perform the following operations. The value of the character is the index at that character in the English alphabet. So A maps to 0, B maps to 1, Z maps to 25, okay. And then calculate the sum of all the hash values of the character in the substring of length k. Cool. And find the remainder of the sum when divided by 26. So we have to perform your modulo operation, and we call this the hashed char. Identify the character in the English lowercase alphabet that corresponds to hash char. So hash char is going to be a number, and then we need to map it back to an actual character, right? So the reverse way that we did before. Append that character to the end result. Okay, so that's super complicated explain. So I guess what we'll be getting is a string, and then a number k, and then we just divide the string into k long substrings, and then for every substring we're going to perform this hashing operation where we kind of combine three characters into one, right? Okay, constraints. I would have a question about the constraints. So is it always guaranteed that k divides the length of the s, right? Can s be an empty string? Can k be 0? What are those edge cases? Is it guaranteed that we only get lowercase English letters? Or do we get maybe a none string or null or whatever? Would ask all those things just to make sure. And by the way, it's okay to ask more than you think what you will need. It'll look better when you already collected what you need in the very beginning, should you find out later in the problem that you need some extra information. Right? When you don't want to have to ask halfway through the implementation, oh, by the way, do I have to take care of that edge case? It's better if you checked all of that before. And part of that is to just ask more than you might need. So cool. Right, constraints. So it's guaranteed that k is at least 1. It's guaranteed that our string length is at least k. Nice. And it's guaranteed that the string length is always divisible by k, and that the string consists of only lowercase English letters. Cool. So that eliminates a lot of edge cases for us, and we can just assume we can always perform this this hashing operation, I guess. Okay. So just looking at this example, right now comes the phase where we look at the examples. We could just iterate over a string, and we could. Well, I don't think we have to split the string into substrings. I think we can just iterate over the string, and we compute the hash char at the current. And whenever our index is pointing at, well, our index is divisible by k, that means we need to combine our current, I guess, sum of hash chars into a new character. So I think we can do it in one pass over the string, and then we have to build up a result string. I would probably suggest to use an array so that we append the characters to that array, and then at the very end combine all of them into a new string. Otherwise, you know, we would be building new strings, which is an O of n operation every time we create a new character from 3 characters in the original string. Okay, and here we have, so here in this example, that would be a and b. So we get the numeric values for a and b, which is 0 and 1, that's 1. Then we take it modulo 26, that's exactly what they do here. It's still 1, so that maps to b. Right, so the first character in the result is going to be b. Now the second substring of length k equals 2 is c and d. So the int values are 2 and 3 that they map to, sum is 5, and the result will be the character f. Cool. Here's an interesting edge case where k is actually the length of the string, but we still perform the same operation, right? We take the sum of all the numeric values of these letters, modulus 26 them, return them back into a character. Cool. So I have no further question. I would now ask, you know, are you happy for me to implement this one-pass solution that computes a unit string, blah, blah, blah? And then say yes. And I'll also say, yeah, it's, so this is going to be of n time and space, since the length of the hashed string depends on the length of the original string. Cool. And so I will now write the code. Result is an empty array. And at the end, I said we would join all the characters in result into a new string. Return. Now we're going to iterate over all of our characters in S. So I'm going to do this where I iterate with both an index and I get the character at the current position. To do it like that. I actually don't know if this creates a list or not. Not 100% sure. We could just do it like so, right? Then the character is as at position I. Right. Now, well, what do we have to do? Well, first we have to map it to a number, right? And the way to do that in Python is we can take the ordinal value of a character. That will return us the ASCII value of it. And for, I think, lowercase a, I think the number is 90 or 91, something like that. So to bring it down to 0, because we want to map a to 0, we have to actually subtract the value of the ASCII character a. So now suddenly all of these values will be between 0 and 25. So that's going to be that character. And you think, yeah, I'm also, well, I need to keep kind of track of what is the current sum, right? And well, since it's guaranteed that, you know, the length of the string is going to be at least k, it is safe to use our result array maybe as a temporary storage for the sum. So what we could do is we could just put our running sum as we loop over these characters into here. So what we could do is result dot append, well, actually result at -1. Just going to add this. So we're basically just adding these values together. And now what we do is if I modulo k is equal to, now that's going to be interesting. I modulo k is equal to 0. Well, but we don't want this to happen when, but we need to, I think we need to have an off by 1 thing. So we say I plus 1, but I have to come back to this. And by the way, it's fair in an interview to say, well, you have to come back to check the logic. But here the problem is we just take I modulo k equals 0. Immediately when I is 0, that is true, right? I think we have to increase I by 1 and for this to work. But I'll come back to revisit. And I'll make a little note for myself here. Right. So if that is the case, well, what do we have to do? Well, we have to turn the sum that we have in result. Well, we have to take it modulo 26, but we also have to turn it into a character again, right? And the way to do that is we just use for the character function Python, character function, and now we need to add the ordinal value of a to bring it up again. So what we can do is we can just take value modulo 26 plus that, and we can just assign that value into our character, into our result array. So now we've turned the number in results into a character that can then be appended. Right. So let me now just check with the values of I. We have I. Let's take this example first. So I is going to be 0, 1, 2, 3, and we want to. Well, we want the condition of the if statement to be true whenever we hit 2 characters. So if we say I plus 1 modulo 2, that's exactly going to be 0 when exactly I plus 1 modulo k is 0. So my intuition was correct here. So that's what we have to do. Yeah, and I think that is also pretty much the code. I will now maybe step through an example. Again, we're going to take our example A, B, C, D. So what we'll have is I is going to be 0. We're going to have A is going to be our character. What we're going to put in our result is going to be 0. Next, I is 1, and we have the character B. So we're going to update our sum with +1, so it's going to be 1. But also we have now since I is 1, 1 plus 1 modulo 2 is 0. So we actually have to turn our value of 1 back into a number. So we take our number 1 modulo 26 and we convert it back into a character, and the result is then B, right? If result at 0 was 0, then we would get A, but since it's 1, we're getting B. Nice. So now we have B in our result, and oh yeah, and we also already see a mistake or something that I missed. That is why I go through the code. So now I need to append another 0, and let me see. I have to append a 0 in case. Well, I have to append a 0 in case I have to continue the loop. Otherwise, this will give me an error. However, in the last pass, I don't want to append a 0. So maybe what I should do is I should change where I decide to append a 0. So if I put UK is 0, maybe then I just append. So we will append the 0 every time. Well, at index 0, at index 2, etc. So that would solve that issue. Right. So we have B in our result, but we would append a 0 now since I is going to be 2. In the next iteration where it points at the character C, we would have a 0 in our array. But we are now adding something to 0, and that is exactly the code for A, or the numerical code, for C. That is the value 2, obviously. So 2 plus 0 plus 2 is going to be 2. And, well, this statement doesn't catch since we had I value 2. And 2 plus 1 is 3. Modulo 2 is 1, not 0. So this does not catch. Next iteration of the loop. So I becomes now 3. Our character is now D. And we again have to add the value for the numerical value for D, which is in this case 3. We're going to add that 3, and which is 5. And however, since I is 3, 3 plus 1 is 4, modulo 2 is 0. So now we convert the number here at the end again into a character. So what we do is we take 5 modulo 6. 5 is the fifth, but 0 is A, B, 1, 2, 3, 4, 5, F. So we're going to put in F here to the result, and then we're just joining the result. So with that, I'm fairly confident that this solution is correct. And I will now just do one more scan real quick to see if I have all my colons in place. Append looks good. The addition, there's a dot too much. There's a colon is good. See the bracketing here. So that. All of that looks good to me. So I would run it through the test case to make sure that it is actually okay. And it is. And now I would submit this solution. Yeah, and it works. I think in this problem, I've overcomplicated things a little bit by trying to reuse the result. If I just had a sum that I keep increasing, I think that would have simplified these things a little bit, so I don't have the gymnastic with reading and writing from result and etc. But it doesn't really matter. We solved the problem. On to the next one.